In this video, we wanna review all the basic concepts we have learned this chapter by working on the following problem. In the next video, we're gonna show a faster way to do this, which actually also work when we get angles that are not very nice. But for now, for the purpose of review, we are gonna break this down. I'm gonna put timestamps for every step so that you can just skip to the step that you don't know how to do. Our plan is as follows. We want to find sine inverse of sine of 7 pi over 6. That looks like a lot of word, very intimidating, but don't panic. We can just unpack this one at a time. We'll break this into 3 main steps. First, we're gonna find where this angle 7 pi over 6 is. Next, we're gonna find sine of 7 pi over 6. To do so, we'll first review for you what's the definition of sine of an angle that's bigger than 90 degrees, and how you would actually use that definition, as well as whatever you know about the 30, 60, 90 degree triangle to find sine of 7 pi over 6. Now once we have unpacked what sine of 7 pi over 6 is, you'll see that that's minus 1/2. Then we want to find sine inverse of minus 1/2. So in that last part, we'll first review for you very quickly what's an inverse, and then what's sine inverse. Then finally, how do you actually find sine inverse of minus 1/2? Throughout this process, you should observe that actually you didn't even need to compute this stuff. You didn't need this step. You didn't actually need to know what sine of 7 pi over 6 is. If you can see how to do that, then you'll know how to do this problem, which we'll discuss in the next video. Alright, so let's try. Alright, so first, where is 7 pi over 6? Well, some of you will be able to see that this is just pi plus pi over 6. So to arrive at the terminal side of this angle, right, you start from here, you go pi, and then you go pi over 6. So this is the terminal side. On the other hand, if you do not see that, then let's do the following so that you can build some sense about where the angles are. Remember that pi converts to 180 degrees. That means that pi over 6 converts to 30 degrees. Right, remember we're just dividing both of these by 6. So let us see where 7 pi over 6 is. Right, so this is 1 times pi over 6. This is 2 times pi over 6. This is 3 times pi over 6. This is 4 times pi over 6. This is 5 times pi over 6. This is 6 times pi over 6. And now here we are at 7 pi over 6. Thus this would be the terminal side of the angle 7 pi over 6. Though, as I claim, you don't actually really need to know exactly where this angle is to do this problem. Okay, so now let us unpack the next step. What is sine of 7 pi over 6? What is the definition of sine of 7 pi over 6? Now some of you will be trying to use SOHCAHTOA here. You'll say, oh, let's just form a right triangle with the angle 7 pi over 6, right? And then sine of 7 pi over 6 will just be opposite over adjacent. And what's the problem with this? Well, the issue with this is that this angle is not acute. It doesn't look like this, right? As we see here, this angle goes all the way there. So you cannot really use this to form a right triangle. And recall that was why when we want to extend the definition of trig functions to angles that are bigger than 90 degrees, we use the unit circle. Actually, we do not need to use the unit circle per se. We can use any circle of any radius r. The idea is, roughly speaking, for every angle alpha, instead of thinking of sine alpha as the ratio of opposite over adjacent, we're going to think of it as the ratio of y-coordinate over radius. Let us quickly review for you if you forgot this. For an acute angle, right, to find sine of alpha, you just draw any right triangle with one angle being equal to alpha, and you take this ratio, right? Well, observe that the following construction will also give you the same result. Say, you start here from the origin, and this is the positive x-axis, and you rotate counterclockwise by alpha to get this ray here. Then you can take any point on this ray. And observe that then the y-coordinate of this point divided by this radius is just exactly equal to this opposite divided by this adjacent. So we could also think of sine of this angle as this ratio of this y-coordinate over this radius. Now, so why do we even bother to do this if this is just giving us the same thing? Well, it's the same thing in the case the angle is acute, but it's different in the case when the angle is bigger than 90 degrees. For if an angle alpha here is bigger than 90 degrees, there is no notion of opposite, whereas we can still define the notion of the y-coordinate of a point on this ray. So if this angle is alpha and I need to find sine alpha here, I can just take this y-coordinate and divide it by this radius. Usually we like working with a unit circle because in that case the radius is just 1, and so sine of alpha is just exactly the y-coordinate. For example, let's come back here. From what we've discussed, what do you think sine of 7 pi over 6 is? As we have mentioned, the angle 7 pi over 6 has terminal side here. This is the terminal ray of this angle. If we're working with the unit circle, then this sine should be the y-coordinate of this point here. So, what is this y-coordinate? Well, to find that, you'll need to observe that we have a copy of the 30-60 degree triangle here. Actually, you should be able to see that we have many copies of this 30-60 degree triangle throughout this circle, but we're only going to use this one right now. Now you need to remember, what are the side lengths of this 30-60 degree triangle? Well, technically, you don't need to remember per se because we can find that out, right? So, let's double this triangle. Now, what is special about this big triangle? Observe that all the angles here are 60, so this is an equilateral triangle. Thus, what do you think this is? Well, if this is an equilateral triangle, then this is 1, so this must also be 1, and thus this side being half of this must be 1/2. Alright, so we got 2 sides down. How would you find this remaining side? Well, there's only one theorem you know that relates the sides of a right triangle. See if you can tell what that is, and then you'll see that if you apply that theorem, you'll find that this is square root of 3 over 2. So with this information, can you tell me, what is sine of 7 pi over 6? What is the y-coordinate here? Now, some of you will say that, okay, look, this side here is exactly equal to this, so this sine 7 pi over 6 must be 1/2. And what's wrong with this answer? Well, 1/2 is indeed the length of this side here, but recall that we define this sine not as this length. We define it to be the y-coordinate. Since this point here is below the x-axis, this y-coordinate is actually minus 1/2. And so you would say that sine of 7 pi over 6 is minus 1/2. Alright, so we have broken down 2 parts in this problem. We have found what this angle is, and then we have found what sine of this angle is. Though, again, as I said, that's not really necessary, but let's proceed with this. So now we want to find sine inverse of this, which means we want to find sine inverse of minus 1/2. To that end, we need to quickly review what sine inverse means. Recall that previously, when we talk about exponential and log, we've talked about inverse operation. We have established that somehow finding inverse is the same thing as undoing, and that's the same as solving equation. For example, the inverse of the function husband on the set of monogamous heterosexual married women, the inverse of that would be the function wife. It maps Harry to the woman whose husband is Harry. Similarly, the inverse of the function x cubed is the cube root, because it should map 8, right, to any number whose cube is equal to 8. So similarly, sine inverse of, say, minus 1/2 should be some angle alpha whose sine is equal to minus 1/2. But I lied a little bit. If you remember what we said in class, this is not the full definition yet. What's the problem with this definition? Well, the problem with this definition is that there are many angles whose sine is equal to minus 1/2. For example, here we have that 7 pi over 6, right, 210, but we can go around the circle one more time, and up here, that's the angle 570, and it also has sine equal to minus 1/2. Or we can go all the way here, right, to the angle 330 degree, which is 11 pi over 6. That also has sine equal to minus 1/2. Or we can subtract 360 from that and think of that as going clockwise 30 degree, right? So this is the angle minus 30. That also has sine equal to minus 1/2. And we can keep going around the circle this way or in the other way, so there are infinitely many options for alpha. Now what's the problem if there are infinitely many options for alpha? The problem is then if we define sine inverse of minus 1/2 to be the alphas, such that sine alpha is equal to minus 1/2, right, to be the solution of this equation, then sine inverse cannot be a function. A function can only have one output for every single input. When you click the sine inverse button on your calculator, you don't want it to output infinitely many angles, right? It will crash. You want it to just tell you one angle. And that is why we need to make a convention. We need to decide if you plug in sine inverse minus 1/2 in the calculator, which amongst these infinitely many solutions here should the calculator give you. And as a community, we have decided that we would only pick the angle alpha that lies between minus pi over 2 and pi over 2, which in this case that would correspond to the solution minus pi over 6. Now be careful here, you need to distinguish between the terminal ray and the angle. So some of you will look at this condition here and say that, okay, so we've decided that sine inverse of any number should be an angle, right, whose terminal psi lie in here. That's correct. But then you mistakenly conclude that, well then, sine inverse of minus 1/2 should be 11 pi over 6, because the y-coordinate of this point is indeed minus 1/2, and the terminal ray of this angle lie inside here. Well, observe that we do not just require that the terminal ray lie inside the region here, because if we only require that, we will still have infinitely many solutions, right? Because there are infinitely many coterminal angles. So you are right that this is gonna be the terminal ray of the angle sine inverse of minus 1/2. This is gonna be the terminal ray of alpha. But there are many angles alpha with that terminal ray, and we only want to pick the one that lies between minus pi over 2 and pi over 2. So the answer should actually be minus pi over 6. Note that the convention is that we give sine inverse in terms of radian. So the answer to our question here is that sine inverse of sine of 7 pi over 6 is equal to minus pi over 6, because sine of 7 pi over 6 is equal to minus 1/2. And now sine inverse of minus 1/2 is equal to this angle, minus pi over 6, because the terminal ray of this angle here on the unit circle has y-coordinate equal to minus 1/2. And moreover, this angle lies within this range. This is the range of sine inverse. Right, so that's how you would solve this problem. Now we took a really long way because I wanted to review some basic concepts with you. But actually we can solve these types of problems in a much faster way without even knowing what these are. And let us do that in the next video.